Alright, so this is the 9th video in the series of data analysis and visualization with Python course. Let's continue from where we left off in the last video, where we learned about changing data, operations and manipulation of DataFrame in Pandas, add, remove and change columns, and then save the DataFrame in a CSV file. So in this video, let's continue that, and we will be taking a look at the following topics of data cleaning: filtering via conditions and changing via conditions. So let's start off with some advanced Pandas things, and the first thing is going to be data filtering. So when we want data of particular type, we filter the data to get only specific rows of data depending on particular value of a column. Or to put simply, we use filtering techniques to get all the entries of data that has something in common. So let's just import pandas and files from Google Colab. Then import the same CSV file called championdata.csv as used in the last video. I will put it in the bottom unit of this video as well. And finally, print out the first few values of the file. Okay, so now notice that class column here contains many classes of champions such as mage, warrior, assassin and tank. To see what unique values lie in a column, meaning how many and which classes are champions divided into, we can use the .unique function. So we type data subclass .unique and then run this. We can see on the screen that all the entries in the file are divided into these classes. The idea here is to filter the data to get rows of only those champions that belong to, for example, the tank class. For some interesting information, the champions belonging to the tank class have a lot of health and armor and are very hard to fight. So let's go ahead and get all the champion rows that have the tank class. To do that, recall the concept of Boolean masking, where in NumPy array, we wanted to access all the values of an array that met a specific condition. We used the conditional check inside the indexing operators, and it gave us the list of all the values of the array where the condition was true. Similarly, we know that we access data in DataFrame by using the ilog and log attributes. In this case, we can use the log attribute and then use the conditional statements inside the indexing operators to get rows for which the conditional statement is true. So if we wanted all rows where the value under the class column is tank, we can just type data.ilog, and in indexing operators we can type data subclass equals tank and then run this to see what it returns. On the screen you can see that it has returned all the rows from the data frame where the class value was tank. We can actually use multiple conditional statements together by using the and or operators. So for example, if I wanted all the rows where class value is tank and the damage is more than 1, I can do something like data.log subdata subclass equals tank and data subdamage is greater than 1. Notice that the both conditions are in parentheses. This is important when filtering data in Pandas library, but is not required normally in Python outside the library when making conditional statements. We can also see that keyword of AND is a symbol instead of using the normal AND keyword in Python. This is just the way Pandas is defined, and of course you can look this up anytime on the Pandas documentation provided online. And now let's run this. So we can see that in each of these rows, both the conditions are being satisfied and the class is tank and the damage is above 1. See how easily we are able to filter data on different conditions. So you might want to pause the video and practice a little to get data by conditions creatively before moving on. Similarly, we can use the vertical bar to indicate the OR keyword while filtering data in the data frame. Alright, so let's say once we have finished the data according to the conditions we want, we should have a way to save that filtered data in the program and should be able to export it in the separate file. Well, we can just make a new variable and assign it to the filtering operation in the .log attribute like we did above, and it will be saved as a separate data frame. So only tanks equals data.log subdata subclass equals tank, and then printed out the only tanks data frame. Then of course we can just put this in a CSV file and download it. So you might have noticed something odd, which is that the index here is the old index of previous data frame called data. So this can sometimes create problems when we will be accessing and changing things in the only tanks data frame. So what we can do is reset the index of this data frame by using the .resetIndex method. This method does not change the data frame but returns a new one, so which we can resign, such as only tanks equals only tanks.resetIndex. And now if we run it, we can see that the index has successfully been reset and it starts from 0. So we are going to continue some more important analysis techniques throughout the next 2 or 3 videos, and then move to solving small but real world data analysis problems in the form of projects. So that's it for this one, and I'll see you in the next video where we take a look at what regex filtering is and then the conditional changes in the data.